Okay, so here's some information, a lot of information. So consider the following information for three stocks, A, B, and C, and then the returns are positively correlated, but they're not perfectly correlated. That means the correlation coefficients are between 0 and 1. And then you're given the expected returns, expected standard deviations, and the betas. Portfolio P has half of its funds invested in stock A and half is invested in stock B. Portfolio Q has 1/3 of its funds invested in each of the three stocks. The risk-free rate is 5%, and the market is in equilibrium. So what is the market risk premium? So what I need to do is find the beta for one of the two portfolios, either portfolio P or portfolio Q. And if I look at portfolio P, since it says half invested in A and half invested in B, that sounds like the shortest equation. So the beta for a portfolio is equal to the weight times the beta of each stock. So for stock A, we'd be looking at right here, 50% of the money in stock A with a beta of 1 plus 50% of the money in stock B with a beta of 1. And so we can see that that's just going to equal a portfolio beta of 1. And since we're solving for market risk premium, we're going to look at portfolio P is equal to the risk-free rate, use the CAPM equation again, the market risk premium, and then times the beta of the portfolio. So remember, we don't have to just use this for individual stocks, this CAPM, but we can also use it for portfolios. That's the key difference here. And the risk-free rate, they said, is 5%. And this is going to be plus the market risk premium times 1, because that's what we got for the beta of the portfolio. And the return for the portfolio is equal to 10%. Really, if we look at, if I had half my money in stock A, 0.5 times 10% plus 0.5 times 10%, then I'm going to have an expected return. So that could be another thing. The expected return is equal to the weight of A times the return of A plus the weight of B times the return for B. So the expected return, and I'll say for the portfolio, is equal to 0.5 times 10 as a percent plus 0.5 times 10. And then I would just get the expected return here is 10%, and that's what I would use over here. So I set this equal to 10%. So I can tell if this is 1, then I know that 5 plus 5 is going to equal 10. So the market risk premium is equal to 5%. So it's kind of a strange little question, but that's what it was. And then we have down here, question 7, given the following information, determine which beta coefficient for stock A is consistent with equilibrium. The expected return for stock A is 11.3%. So I would say R, or 11.3, is equal to the risk-free rate, 5%, plus the market risk premium of 5% times the beta for stock A. And so I just, subtract 5% from both sides. And so that would leave me with, let me just write it out like this, 11.3 minus 5% is equal to 5% times the beta for stock A. I would divide both sides by 5%, and these two would cross out, and that would leave me for the beta for stock A. So 11.3 minus 5 divided by 5 gives you 1.26. So answer B. And I didn't have my calculator with me, so I just did it like that. Okay, so here's coefficient of variation. I'm looking at the end, like what's the question here? So the coefficient of variation, so I'm not even going to look at the question yet. I'm just going to say that's risk divided by return. And remember, the lower that number, the better. And risk is the standard deviation divided by the return. So that's the only two numbers they could have given me here. So Ching Inc. is considering a capital budgeting project that has an expected return of 25%. So I know that 25% goes here, and a standard deviation of 30%. So I know 30% is the risk, and it goes up there. And the coefficient of variation, if I divide that, actually, I do have my calculator. 30 divided by 25 is 1.2. And it's not a percent or anything, it's just a general number. And the lower that number, the better. So remember, coefficient of variation is a very short calculation. Whoops. Okay, now we get to the long type question. So Carson Inc.'s manager believes that economic conditions during the next year will be strong, normal, or weak, and she thinks that the firm's returns will have the probability distribution shown below. What's the standard deviation of the estimated returns? So the very first thing before you can do standard deviation is you have to get the expected return, and then you can solve for the standard deviation. So for part 1, the expected return is going to equal the probabilities, 0.3 times 32% plus 0.4 times 10% plus 0.3 times negative 16%. Okay, so I'm using my graphic calculator. And I'm going to put in negative 16 for that last number. And so I get this is equal to 8.8%. So you have to have this number first, because the next part we have to find the standard deviation, and you always have to have the expected return for that. So another way to write standard deviation is this way. And if you remember, we had to write a long equation, so I'll put a bracket. So first you take the first probability, so 30%, times the return in that state, 32%. And you could actually, let's just write all this in decimal form, so it'll be less confusing. Take the first return of 32% and put it in a decimal form, subtract out the expected return, and square that difference, and it gets multiplied times the probability. Plus the next one, 0.4% probability of getting a 10% return minus the expected return, and that's squared, and then plus 0.3 30% chance of getting a negative 16% return minus 0.088, and that's squared. To get the standard deviation, we will have to raise this to the 1/2 power, everything that you get in here. So let me just get the first number. So I'm going to do 0.32 minus 0.088 and square it. And I'm going to multiply this 0.053 times 0.3. So I get 0.0161, I don't know, 472. I guess I'll go out to a lot of decimal places. And then the next one, 0.1 minus 0.088, enter, and it's my graphing calculator, and I'll square that difference. I get a really small number, and I'll multiply it times 0.4. And since it's so small, on my calculator it's giving me like e to the -5. I'm just going to write 0 and hope that it doesn't mess us up. And then the next one is let's see, we start with negative 0.16 minus 0.088, and I'll square that difference, and I get a 0.0615 here, and I'll multiply that times 0.3, and I get 0.01845512. The reason why I'm going out to so many decimal places is just in case they have a very precise number in the answer up here. So I'm going to add that, since I already have this number right here in my calculator, plus the first number I got, 0.16, make sure I'm doing that right, 1472. And so I get, this is equal to 0.0345984, and I need to take the square root of this number to get the final standard deviation. So I hit the square root function and type in the number again. And I get 0.186, which is 18.6%. And so there's the answer here, answer B is 18.62. That's probably because that number I just put 0, it was just so small, it made that small of a difference. So 18.6 or 18.62%. So that was the one, like, if you remember from the PowerPoint lecture, we had high-tech collections and USR company, and they showed us, they kind of just calculated already the standard deviations for each of those, and I said we would work an example, and so here's the example for that one. And I believe that that's it for the example problems for this chapter.